Welcome guys! In this video we're going to analyze what is an electric vehicle and how it works. Moreover, at the end of the video we will talk about wireless power transmission and its applications. So, what is an electric vehicle? Basically, it's a vehicle which uses one or more electric motors or traction motors for propulsion. It may be powered in two different ways. The first one is through a collector system by electricity from off-vehicle sources, or may be powered by batteries, solar panels and fuel cell contained direct into it. There exist electric vehicles for a lot of different scenarios. For example, the most common are road and rail vehicles, but also underwater vessel aircrafts and even electric spacecrafts. EVs first came into existence in 19th century, but nowadays they have been more and more famous due to technological developments and an increased focus on renewable energy, in order to decrease the impact of vehicles on climate change. One of the most common technology used in electric vehicles are lithium-ion batteries. Indeed, most EV use this type of battery because they have high density, longer lifespan and higher power density in respect to other batteries. Obviously, there are also some drawbacks, for example safety, thermal breakdown and cost. Indeed, lithium-ion batteries must work within a specific temperature and voltage range in order to be safe and efficient. A very important thing to keep in mind while talking about electric vehicles is the functioning of the electric motor. As a common internal combustion engine, its power is expressed in kilowatts. But the advantage of the electric motor is that they are able to deliver their maximum torque over a wide RPM range, meaning that they are able to deliver the maximum torque even when a common vehicle equipped with an internal combustion engine can't. To clarify this concept, let's consider two vehicles, one completely electric and the second with an internal combustion engine, both standing still. The first one will have better performance at the start, because in this condition it's very important to deliver all the possible torque in shortest possible time. And obviously the electric vehicle will get the maximum torque as soon as the driver pushes the throttle. While the driver in the second car will have to wait the right RPM range before getting the maximum torque available. Another thing to keep in mind is that the process of converting electrical energy into mechanical energy doesn't come with no losses. Approximately 90% of the energy from the batteries is converted to mechanical energy, and the losses are especially in the motor and drivetrain. Usually, EV vehicles have an efficiency of about 60%, in respect to conventional gasoline vehicles, which have a much lower efficiency with just 20%. The key point is the environmental advantage over combustion engine. Indeed, EVs release no tailpipe air pollutants at the place where they are operated. So, as we said, electric vehicles are much more efficient and moreover they also produce less direct emission. But are EV really emission-free? Well, the short answer is no. They do rely on electrical energy that is generally provided by a combination of non-fossil fuel plants and fossil fuel plants. So EVs are charged with electricity that is generated by means that have health and environmental impacts. Consequently, EVs can be made less polluting overall by modifying the source of electricity. In some areas, consumers can ask utilities to provide their electricity from renewable energy. We can conclude stating that the air emission from producing and operating an EV can be less than or greater than those of producing and operating a conventional vehicle, depending on the regional electricity grid mix, timing of EV charging, driving patterns, climate, the set of air emission under consideration, and the specific electrical and conventional vehicle designs being compared. Now, let's use the concept of smart grid seen in previous video in order to analyze this very interesting idea. Since EVs can be plugged into the electric grid when not in use, there is a potential for battery-powered vehicles to even cut the demand for electricity by feeding electricity into the grid from their batteries during peak use periods, such as mid-afternoon air conditioning use, while doing most of their charging at night when there is unused generating capacity. This vehicle-to-grid connection has the potential to reduce the need for new power plants, as long as vehicle owners do not mind reducing the life of their batteries by being drained by the power company during peak demand. Well, the question now is, how have the nation reacted to this new technology? In May 2017, India was the first to announce plans to sell only electric vehicles by 2030. With nearly a third of all cars sold in 2017 of all new cars either fully electric or a hybrid, Norway is the world leader in the adoption of electric cars, and like India pushes to sell only electric or hybrid cars by 2030. The other nations followed the lead, with France and UK announcing the plan to ban the sale of gas and diesel cars by 2040. Austria, China, Denmark, Germany, Ireland, Japan, Netherlands, Portugal, Korea and Spain have also set official targets for electric car sales. Many governments offer incentives to promote the use of electric vehicles with the goals of reducing air pollution and oil consumption. Some incentives intend to increase purchase of electric vehicles by offsetting the purchase price with a grant. Other incentives include lower tax rates or exemption from certain taxes and investment in charging infrastructure. Another interesting concept is the wireless power transmission, or electromagnetic power transfer. It is the transmission of electrical energy without wires, which are usually used as a physical link. In a wireless power transmission system, a transmitter device driven by electric power from a power source generates a time-varying electromagnetic field, which transmits power across space to a receiver device, which extracts power from the field and supplies it to an electric load. This technology could be fundamental in order to reduce drastically the use of the wires and batteries, thus increasing the mobility, convenience and safety of an electronic device for all users. Wireless power techniques mainly fall into two categories: near field and far field. In the first one, the power is transferred over short distances by magnetic fields using inductive coupling between coils of wires or by electric fields using capacitive coupling between metal electrodes. In far field, also called power beaming, power is transferred by beams of electromagnetic radiation, like microwaves or laser beams. In this way, it's possible to transport energy for longer distances if properly aimed at the receiver. For example, a useful application are solar power satellites. The problem of this kind of technology is that it could be dangerous for living beings, and for this reason it's important to limit the exposure of them to the electromagnetic field. Well, that's it for this video. I hope that it has been useful for you. If you liked it, please leave a like and tell me in the comments what do you think about these technologies. Moreover, do not forget to subscribe to my channel. See you in the next video.